Have you ever wondered what it would be like to instantly appear somewhere else in the blink of an eye? Welcome to the fascinating world of teleportation, a concept that has captured the human imagination for centuries. Teleportation, in essence, is the instantaneous transportation of an object or a living being from one location to another. Imagine, if you will, standing in New York one moment and then, in the blink of an eye, standing on the sunny beaches of Hawaii. How about sending a vital piece of medical equipment from a warehouse to a remote hospital in an instant? Yes, these examples sound like they are straight out of a science fiction novel, but they encapsulate the allure of teleportation. It's a concept that challenges our understanding of reality and breaks the barriers of time and space. This mind-boggling concept has been a staple in science fiction. But could it become reality? From Star Trek to Harry Potter, teleportation has sparked our imaginations in countless ways. The idea of instantaneously moving from one place to another has been a compelling part of many science fiction narratives. In Star Trek, we see the iconic transporter beaming characters across space in an instant. In Harry Potter, characters use flue powder or apparition to journey across vast distances in the blink of an eye. These imaginative depictions have shaped our perception of teleportation, turning it into a symbol of advanced technology and magical prowess. They've painted a picture of a world unbound by physical distances, where one can be anywhere at any time. These tales have not only entertained us, but also inspired real-world scientific inquiry, as researchers ponder over the possibility of making teleportation a reality. While teleportation may seem like pure fantasy, scientists are actually exploring the possibilities. The world of quantum physics might hold the key to making teleportation possible. At its core, teleportation would involve the precise manipulation of matter on the smallest scales, something quantum mechanics is uniquely suited to explain. One of the most intriguing phenomena in quantum physics is quantum entanglement, a process where two particles become intrinsically linked, behaving as a single entity no matter how far apart they are. This could, in theory, provide a mechanism for teleportation. If we could entangle two particles, then manipulate one, the other would instantly reflect those changes. It's as if we've teleported the state of one particle to another. While quantum entanglement offers a tantalizing hint at the possibility of teleportation, it's important to remember that we're still in the early days of understanding these complex quantum behaviors. There's still a lot we don't know. However, the path from theory to practice is filled with significant challenges. Teleportation isn't as simple as pushing a button on a machine. The scientific challenges are immense. Imagine needing to accurately scan every atom in an object or person, then perfectly reconstructing it at another location. This isn't just about identifying the type and number of atoms. We need to know their exact arrangement, their bonds, and even their quantum state. It's like trying to rebuild a billion-piece puzzle, where every piece is almost identical and constantly moving. Not only that, but the sheer amount of information involved is staggering. To scan a human body, for example, would require data storage capacity far beyond what we currently have. And that's not even considering the energy requirements or the possible risks of errors in the reconstruction process. But it's not just about the science. Beyond the technical hurdles, teleportation also brings up a host of ethical and philosophical questions. If we could teleport, would we still be the same person on the other side? A question that plunges us into the depths of ethical and philosophical considerations surrounding teleportation. Imagine your atoms disassembled at one point, only to be reassembled elsewhere. Is the reassembled you the same you? This conundrum of identity and continuity is a major philosophical hurdle. In the realm of ethics, we're faced with the potential misuse of teleportation. Could it be used for criminal activities? Invasion of privacy? Could it create a new class divide between those who can afford to teleport and those who cannot? Moreover, teleportation raises existential questions. If we can teleport, what happens to the concept of distance in our perception of the world? Will it change our understanding of life and death if we can simply teleport our consciousness into a new body? Teleportation could revolutionize our world in many ways, but what could be its potential applications? Imagine if you could travel from New York to Paris in the blink of an eye. The potential applications of teleportation are as vast as they are exciting. Let's delve into a few. First up, rapid transportation. Just think about it. No more traffic jams, no more delayed flights. You could have breakfast in London, lunch in Tokyo, and dinner in Sydney, all without leaving your day. It's not just about people either. The ability to instantly transport goods around the globe could revolutionize industries, from e-commerce to emergency aid distribution. Then there's the potential for space exploration. Teleportation could make the vast distances of space feel a little less daunting, allowing us to explore far-off galaxies without the need for lengthy travel times. And let's not forget the potential in healthcare. Imagine being able to teleport organs for transplant or even teleporting medicine directly into the human body. While teleportation of humans is still a far-off dream, quantum teleportation is already happening. Quantum teleportation is not about beaming people or objects around. It's a bit more subtle than that. Instead, it's a process that involves the transfer of quantum states between particles. Now let's delve a bit deeper into this concept. At the heart of quantum teleportation lies a phenomenon known as quantum entanglement. This is a bond that forms between two particles, allowing them to share information instantaneously, no matter how far apart they are. Imagine two entangled particles existing in a superposition of states. The moment we measure the state of one particle, we instantly know the state of the other. Now, this is where quantum teleportation comes into play. By manipulating these entangled particles, scientists can essentially teleport the state of one particle to another, thus cloning its quantum information. However, it's crucial to understand that we're not teleporting matter itself, but the information that defines it. Quantum teleportation is a fascinating field of study, but how does it relate to our present-day reality? While we can't teleport ourselves yet, there have been some intriguing developments in the field. As we speak, scientists are tirelessly experimenting and researching in the realm of teleportation. One of the most promising advances is quantum teleportation, a process that involves the transfer of quantum information from one particle to another. In recent years, scientists have been able to teleport quantum information over several miles. This is a significant leap forward, but let's not get ahead of ourselves. Quantum teleportation, as it currently stands, doesn't involve the physical transfer of matter. Instead, it's more like transmitting a detailed blueprint of a quantum state from one location to another. While this might seem a far cry from the teleportation we see in science fiction, it's a crucial step towards understanding how we might one day achieve it. Every giant leap begins with a small step, and quantum teleportation is our first stride into the unknown. Teleportation could have a huge impact on space travel, but how? The vast distances of space could be overcome with the power of teleportation. Imagine for a moment, a universe where the farthest reaches of space are but a simple teleport away. No longer would we need to spend years, even decades, traveling to distant planets or galaxies. Teleportation could revolutionize space exploration, making it feasible to visit distant celestial bodies within a human's lifespan. It could potentially allow us to colonize other planets, as we could instantly transport resources and personnel. Imagine sending not just rovers, but full-scale research labs to Mars or even further afield. Yet it's not without its challenges. How do we ensure the safe teleportation of complex living organisms across such vast distances? And what about the energy requirements which, by our current understanding, would be enormous? These are questions for future generations of scientists to answer. As we look to the future, what role might teleportation play in our society and technology? Teleportation could transform our world in ways we can't even imagine yet. As we stand on the precipice of technological advancements, teleportation could redefine how we conceive of distance and time. Imagine a morning commute that takes mere seconds, or the ability to visit friends and family around the globe in an instant. The world would shrink, and our global community would feel more connected than ever before. But these wondrous prospects also come with their own set of challenges. What happens to our sense of place and home when distance becomes irrelevant? How do we ensure the safety and security of such a powerful technology? And importantly, the massive energy requirements and the intricate complexities of matter reconstruction pose significant hurdles. Despite these challenges, the potential benefits of teleportation are immense. From revolutionizing transportation to transforming space exploration, the possibilities are endless. Teleportation remains a fascinating concept that continues to captivate our imagination and drive scientific exploration.